today's topic of discussion is going to be on time complexity. Now, whenever you analyze the time complexity of any algorithm, the basic thing you actually count is the number of iterations. Now, if you do not know how to count these iterations, you won't know how to calculate the time complexity of the code. So the agenda for today's video is to count all the iterations of an algorithm. So basically, we learn the techniques of counting number of iterations. So before learning how to actually count the iterations, there are a few math concepts that we need to learn. First of all, let us understand the meaning of log base 2n. Now the number of times we need to divide n by 2 to reduce it to 1 is termed as log base 2n. Okay. Similarly, if I have log base ax, that means we need to divide ax x number of times to get 1 as the answer. Similarly, if I have log base ax, then I need to divide x a times till x becomes equal to 1. So I am trying to say x by a will give me equal to 1 after a certain number of counts. That count is depicted by this log base n or log base x. Okay. So in this case, log base 2n will mean that the number of times we need to divide n by 2 to reduce it to 1. Moving on, I hope you know the meaning of this symbol. Whenever we have the square brackets, it means that whatever the limits have been given, it is inclusive of that. And whenever you have the common bracket, it means that it is exclusive of those limits. That means square bracket a comma b will mean numbers including a up till b, that is including b, whereas common brackets a comma b will mean numbers from a up till b excluding a and b. Let's see with the help of an example. If I say 1, 7 in square brackets, this will mean that the numbers will range from 1, 2, 3, 4, 5, 6, 7. Similarly, if I have numbers from 7 to 10, this will mean 7, 8, 9 and 10. Now every time you cannot really count all these numbers. So let us generalize this formula. So if you see here, you can say that the total number of numbers inside this range would be 7 minus 1 plus 1, that is 7. As you can see over here, we have 7 numbers. Similarly, over here, you have 10 minus 7 plus 1. That gives me 4. As you can see here, we have 4 numbers. Let's take one more case. 12, 23. So if we have 23 minus 12 plus 1, this will give me 12. That means 12 numbers will be there in this range. So if I try to write a general formula, it will mean for inclusive a to b, the formula would be, this is a square bracket, the formula would be b minus a plus 1. Okay, great. Now let's move on to the third concept that we will need. Now we need a basic understanding of arithmetic progression. Or AP. Now this would be a series of numbers where any two consecutive numbers have the exact same difference. Let us understand with the help of an example. We have 4, 7, 10, 13, 16, and the series goes on. And then let us generalize this. So what is the difference between two consecutive items? Here, as you see, difference is 3. Here also difference is 3. Here as well difference is 3. And here as well the difference is 3. So I can say the starting term would be A. The next term would be A plus the difference, that is D over here. The next term would be the previous term plus D, that is nothing but A plus 2D. Next term would be A plus 3D, and so on. So if I consider this, that A is my first term, D is the common difference, and N is the number of terms occurring in the series, then I can make the formula for the summation of this arithmetic progression. So if you have done this in your basic mathematics in school, you would understand the sum of AP would be n by 2 into 2a, that is my first term, plus n minus 1 multiplied by the difference d. Similarly, if we have n natural numbers, if we have natural numbers like 1, 2, 3, 4, 5, 6 and so on, meaning that there is a difference of only 1. I can safely say that the formula for the summation of the first n natural numbers would be n into n plus 1 by 2. Okay, this was the basic knowledge that you need to require for your arithmetic progression. Let's move on to the fourth concept. Fourth concept is of geometric progression. Now, geometric progression is a series of numbers where every two consecutive terms will have a common ratio. Let's understand with the help of an example. We have 5, 10, 20, 40, 80, and the series goes on. So let's try to figure out the ratio of these two numbers. The ratio would be 10 by 5, that is equal to 2. Here also you will notice that the ratio is 2. Here as well the ratio is 2, and here as well the ratio is 2. So if I try to make a general series for this, I can say the first term being A, the second term would be A into the ratio, let's say R is my ratio. The next term would be AR into R, that is AR square. The next term will be again multiplied. I'll have AR cube, then I'll have AR to the power of 4, and so on. A would be my first term, R will be the ratio of two consecutive terms, and N would be the number of terms in the series. So if I want to find out the sum of the first n terms of a GP, I can make the formula as A into R to the power of n minus 1 divided by R minus 1. And obviously it's a given that R would obviously be greater than 1. Okay. So these were the four concepts that we needed to understand and count the iterations in an algorithm. In the next video lecture, we'll have multiple examples and we'll learn how to actually count all these iterations applying all the four principles that we have just learned. If you have liked the video and you found it helpful, please like the video, comment down below and subscribe to my channel. I'll see you next time.